In this video, I'm going to show you how to do some very simple statistical analyses on a data set. Here we have results from an experiment in which a bacterium was measured for its concentration in water in a pre-filtered water sample or a water sample that had been put through a syringe filter. And you can see that there are 4 different trials. And so for trial 1, here are those pre and after filtration measurements. The same for trial 2, 3, and 4. We're going to make 2 calculations here. We're going to calculate the average or the mean, and then we're going to calculate the standard deviation, which I'm going to abbreviate as such. To calculate the average, what we do is we first hit the equals button, and you'll be able to watch up here this calculation as I'm typing it in. I'm going to hit equals, and then I'm going to type in average, and you'll see that it's posting right underneath here as well, so that you don't have to type it if you don't want to. And then it's going to pull up parentheses here, and the easiest thing to do is just highlight all of those numbers within the row that you want to calculate an average for. If I hit enter, here is that average from these 4 trials. Now, I could just hit equals average again and do the same calculations below as such. An alternative way I can do this to save some time is actually just to grab this little box in the bottom corner over here and pull it down, and this allows for somebody to do a calculation of averages for multiple pieces of data if, for example, you have a really large table. You can see that when I pulled it down, it formatted this lower box in the same way as the upper one, so both of them are in scientific notation, where this is 6.72, and the E plus 0.07 means 6.72 times 10 to the 7th power colony forming units per milliliter. To calculate standard deviation, we follow a very similar setup, and the abbreviation for this one is STDEV. You're going to see that there are 2 of them, a .P and a .S. You'll want to use the S. P stands for population and should only be used in cases in which you've done every single measurement within a population. For example, if I were measuring statistics for a population of students. But since we have not performed an infinite number of trials, we'll choose the .S. And again, by highlighting these 4 pieces of data, hitting enter, it calculates for us a standard deviation for these averages. And that gives us an idea of how spread out are these 4 pieces of data. Are they highly clustered together? So is there low variance in the data, or is there a high degree of variance? And just to make life simple for myself, I'm going to go ahead and turn this into a scientific notation to make life easier. And if I go right here to scientific, I can do that and then get an idea of the variability in the data relative to the average.